Welcome to another video series where we focus on permanent magnets and a very specific industry. My name's Michael Brand, and today we are going to be focusing on permanent magnets and use in the medical industry, both in design and in the application. So I have the pleasure today of having with me Andy Robinson. Andy Robinson is with SM Magnetics. Andy's forte is actually working with medical customers, and he's been helping them for many years. And I know you have many, many, many medical customers that you've helped, Andy, over time. But Andy's role within SM Magnetics is to help bring some of these products to market, not as a marketing person, but as a magnetics resource for medical customers. There's a lot of nuances in bringing a medical application or device to market. Andy's forte is on the magnetic side and in the manufacturing side. So it's great to have Andy here. He's kind of our expert in the industry. I've personally worked with Andy, and I've watched him help many companies with their design and with their optimization. So good to have you here. Andy, I also understand that not only do you work very closely with the medical community, but you also work very closely with the higher ed community, colleges and universities. Is there a reason? I mean, is there some tie-in between these two?
Actually, yes, there is. A lot of medical innovation takes place at the university level. Okay. We've got research students getting their bachelor's, PhDs, masters, and they're doing just the latest and greatest in medical innovation. And that happens at the university level. Sometimes you'll see medical companies that are backing this research. So they tie in together a lot, actually.
Do you work with these colleges, universities just within the United States, or is it global, or what's your reach on this?
Global.
Great. Yes. Well, hopefully you get to go visit all of them. So
that'd be great.
Yeah. What we would like to do in this video series is we would like to take 9 different topics, Andy, and ask you some questions around these 9 different topics. Specifically, these topics are going to be first, coatings and platings on magnets. Second topic will be applications for in-body use versus out-of-body use, in medical. Third would be use of micromagnets. Fourth, surrounding materials and how they have influence or effect on the magnetic design. Fifth, environmental influences, which sometimes I guess gets overlooked from what I understand, but environmental influences. Six, simulations and optimizations and the importance of those. 7, testing requirements as you see them and as your customers see them. 8, intellectual property protection and NDAs, and we're gonna wrap it all up with topic number 9, which is record keeping. So what I'd like to do, Andy, is maybe spend, say, 3 to 7 minutes on each topic to get an overview to help those that maybe are in the medical community or the medical design community. So how's that sound?
That sounds great.
All right, great. Okay, Andy, let's get started with the very first topic, which is coatings and platings.
Okay.
Again, we are here with Andy Robinson, who is the business development and technical resource to the medical industry for SM Magnetics. And the topic that we're talking to him about in this section is coatings and platings on permanent magnets. So Andy, can you start by explaining what is really the definition of a coating or a plating?
A coating or a plating would be really any material that we are going to cover a permanent magnet, in this case, a neodymium magnet with, to protect the magnet and in turn, protect a patient.
Is the coating important? I mean, why is this such a big deal?
It's a big deal because a neodymium magnet without any plating can start to oxidize and rust. And a magnet that is inside of a body, that's not a good thing. We don't want to have neodymium particles that are breaking away, floating around within the bloodstream. So we need to make sure these are coated.
Okay. Are there specific coatings that are used in medical applications? And specifically, Andy, if I can ask, are there are there coatings that are more appropriate for in-body use versus a coating that's for out of a body use?
Absolutely.
Mhm.
Uh, the common platings that we use for in-body use are going to be perylene, gold, titanium nitride, and rhodium.
Okay.
All four platings are used within the body. Uh, Nickel can be used within the body as long as the magnet is hermetically sealed.
Okay. Do you see that happen a lot, Andy, where it does get hermetically sealed?
I wouldn't say a lot, but it does happen.
Okay. Okay. And then that's in the body, those are good. So out of the body, is it anything goes as far as out of body coatings?
It can. It depends on the application. The standard would be nickel plating, but there are considerations that you have to look at. And we'll get into that when we start talking about the design.
Okay, great, great. Are these coatings really thick, or what are they like?
No, most of them are pretty thin. Your standard nickel plating can range from 10 to 25 microns.
Okay.
Gold plating, the thickest it would go is 1 micron. The standard is actually 0.1 microns.
Mhm.
Perylene is going to be thicker than gold for sure, and you can actually make it thicker,
Mhm.
usually ranging probably around the nickel plating thickness of 10 to 25 microns.
Okay.
Rhodium plating is also going to stay in the same thickness range as gold.
Mhm.
Usually the standard is 0.1 micron. You can go a lot thicker in rhodium, but it's a very expensive coating, so your cost will start to increase.
Okay, great. And what can cause problems with the coatings? Are there things that can cause a problem with coatings?
Absolutely. Depending on the application, the biggest thing we really look at is fluids.
Okay.
Just sterilization can cause some issues, but then we have to look at what other fluids will the magnet be exposed to, and it may not be sterilization.
Mhm.
That could just be the application itself. They're sitting in a solution for a period of time, so that solution can eat away at the coating. So understanding what that is very important. There are other things that can actually hinder a coating, and that's abrasion. So if you are doing some press fitting, or if your magnet gets hit, if it's with a knife or even a paper clip, you
Mhm.
can scratch the coating off. Handling can also damage coatings. Perylene is one of those. If not handled properly, you could rub the perylene right off.
Okay. So Andy, to wrap this section up, it sounds like for someone like you, really understanding and knowing everything about the application is really important. But do you always know about the application, the final application?
No, we don't.
Okay. But so the more information, the better, basically, is what it comes down to. That can help.
Absolutely.
Okay.
Absolutely.
Okay, very good. Okay, Andy, let's do this. Let's move on to the next section. I think we're going to overlap in some of these answers, but this is great. The next section will be magnets for in-body use versus magnets for out-of-body use.
Okay.
Okay, Andy, we would like to, as we said, migrate into section 2 of this video. And section 2 is talking about permanent magnets now that are used in the body for medical use versus out of the body for medical use. So can you give me some examples of magnets that are used in the body and some of those applications?
Well, in the body are going to use micromagnets, some very small magnets. I do have some examples I can show you, but they're very small.
Okay.
Uh, some examples are going to be, this is actually a line of different cube magnets.
Oh,
You may even actually see a through hole in there.
okay.
Um, so
Yes.
that's one example, very small. Uh, and they're going to be used, really micromagnets are going to be used in different catheter applications and devices. And this goes beyond, urinary catheters. We have intravenous catheters and
Mm.
arterial catheters that we'll use them in as well.
Okay, great. Can you give some examples on the other side, magnets that are used out of the body?
Well, certainly, really, it's anything goes on that one.
Okay.
Uh, Anything from a simple cylinder magnet here.
Okay.
You even have even a micromagnet. Like this little disc magnet here. It's very
Okay.
small,
And
but those are going to be used for different applications.
Okay. And when magnets are used out of the body, should they be considered not a medical magnet?
No, they should still be considered medical,
Okay.
but they will not have, usually they will not have as tight restrictions as in the body will.
Okay, you mean tight restrictions like FDA requirements or something? Is that
Absolutely, absolutely.
okay?
The
Okay.
the biggest concern for out of the body magnets is contact with skin.
Okay, contact with the skin. I understand nickel's a problem sometimes with people that have an allergic reaction. Is this the case?
Yes, that's definitely the case.
Okay. So is it, when a medical customer, when one of your medical customers is bringing a product to market that is in body versus out of body, what do you see as the main differences by bringing those to market?
Bringing them to market, it's going to be time. Time is a big factor. Out of the body takes less time to get to market simply because you don't have to go through as many testing or iterations, really, especially when it comes to the FDA.
Okay.
In body is going to take a lot more time because of the FDA and because there's a lot more testing involved, making sure that the design is correct and that it works. And then, of course, as we discussed earlier, plating, very important for in body.
Okay. So Andy, when you're working with these engineers in the medical industry, and you ask them to consider certain things when designing, what would that list be? Those considerations for in body, and then what would that list be of considerations that they should take into account for out of body?
The list of considerations are going to be very similar, actually,
Okay.
and it's truly application dependent. What is it that they're trying to achieve? Is are there torque requirements? Is this for a torque coupling? How's that look? What does that mean for the application? Are we coupling just inside the body, or are we doing inside and outside? So we need to look at that. We need to look, are there pull force requirements for the magnet?
Mhm.
Is this used with a sensor? So are there Gauss requirements for that sensor? And what do those look like? How far away does the magnet need to be from the sensor? So there's a lot of different considerations that need to be taken. And when we talk about torque requirements, the other aspect of that is, what are your materials made out of that are surrounding that magnet? Because that will affect torque, or it can affect torque.
Okay. Okay. So, Andy, I'm going to end this section by asking you, believe it or not, the same question that I asked in the very first section, and that is, what can cause problems in the body with some of these coatings? Now, you had mentioned fluids before, but is there anything else that can cause problems with the coatings in body?
The actual application could cause a problem.
Okay.
If there's any type of abrasion, as mentioned earlier, that's inside the body, depending on how these are used, if there's abrasion, it can scratch the coating off. And if that's not hermetically sealed somehow away from the bloodstream, then we can actually have some problems.
Okay. Okay. Andy, great info. Let's do this. Let's move to the next section. Next section, we're going to talk about the use of micromagnets. And I know you showed us some earlier, which I could see, but if you have some examples, that'd be great. So we're going to move on to micromagnets.
Okay.
Okay, we're back with Andy Robinson again, our SM Magnetics guru. I'll say you as our guru in the medical industry that helps medical customers with optimization of their magnetic designs and get solutions for them. Andy, the topic in this section is micromagnets. My first question is, can you define really what is a micromagnet?
It's a great question. I would say anything that would be less than 3 millimeters in a dimension, but that's not entirely true.
Okay.
And an example I could give of that is if you actually had a cylinder magnet and your diameter was, say, 0.5 millimeters, but you could actually have a length that's 6 millimeters.
Oh.
And so that seems like a very large dimension, but it's still considered a micromagnet because of that diameter.
Okay. Okay. In your experience, Andy, do you what applications do you see micromagnets most used in, and why?
Definitely catheter applications. That would be the biggest one that I see them used in. And it's because they're very small.
Okay.
Catheter tubes, they do range in size, but they try to keep them very small, especially if we're looking at intravenous catheters or arterial catheters. Uh, we have a lot of size constraints.
Okay. Okay. And you micromagnets, from what I understand, require a very different manufacturing process than, say, a non-micromagnet. What are some of the differences that you have experienced with a micromagnet in the manufacturing process?
There are, depending again on the application and the
Okay.
dimensions of the magnet, we're going to look at the manufacturing process a lot more closely to really optimize it and to make sure that we manufacture to the highest yield possible. So, some considerations we'll look at is grinding.
Mhm.
What type of grinding are we doing? Drilling, if we need to drill a hole, what are we looking at? Do we use a standard drill in manufacturing, or are we going to look at a laser drill?
Mhm.
Just to get some tighter tolerances and smaller dimensions.
Okay.
Wire EDM machines, those are also for very precise cutting that we need to do. So those are some considerations that we look at. Tumbling time can also be a big consideration that we have to look at.
And tumbling time, for what reason is that a consideration?
So that goes back to your plating. We need to tumble neodymium magnets to remove the sharp edges so that when we plate, it has a smooth, uniform plate.
Okay.
Whereas if we do not tumble, we'll have sharp edges. The plating can actually hang off and break, and you
Okay.
start taking pieces of the magnet with it.
Okay. Okay. So, Andy, does the small size in a micromagnet, does it have an effect on the actual magnetics, uh, as,
Absolutely.
as well as yield? I know you spoke about yield, but as well as
Yes,
magnetics. Okay.
absolutely it does.
Okay.
The smaller you go, the weaker you go. There's just not a lot of material there. And that goes beyond just magnetic strength. That also goes for its coercivity.
Okay. Okay. Now, I know we talked about, and I'm going to come back to the coercivity question in a second, but I know we talked about coatings in the previous section, but there is something called surface degradation in coating processes and
Mhm.
baths and wash. What do you see as being especially relevant when it comes to micromagnets and this coating process?
Well, that's a very good question. That's something we really do have to look at, and usually something we don't fully understand until the customer is able to do some testing on their side.
Okay.
So we can look at what the surface degradation looks like on a micromagnet, but until we have the finished product and the customer is able to test, we won't be able to fully understand the effects of that surface degradation.
And what causes that surface degradation, Andy?
It's typically the acid that they get washed in.
Oh, okay. Okay. So it's the bath, the acid. Okay, I gotcha. And then let me come back to your coercivity comments. So for coercivity, we're talking about the ability for the magnet to fight against demagnetization for coercivity. But
Yeah.
in micromagnets, why does that become even more of a focus for you?
Well, again, they're micromagnets. They're very small. They have very little mass to work with. And so if depending on their alignment, if they're in an array or if they're lining up to where they're repelling each other, they'll demagnetize each other because there's very little material there. So their coercivity is, well, I don't want to say it's almost non-existent, but in a case like that, it really is.
Okay. Okay. And Andy, can I ask, what's the smallest magnet that you've had to work with?
0.2 millimeters.
Point 0.2 mil, is that like point 0.2 overall? Point 0.2 by what?
It was a 0.2 cube,
A
actually.
point. Can you even see that, by the way?
I cannot.
Uh,
Too
uh,
small.
too small. Andy, okay, great. I'd like to wrap this up and I'd like to head us towards the next section, which is surrounding materials, because not only do we want to talk about the magnet, but we want to talk about what's going on around the magnet in an application. So let's head to the next topic.
Okay.
We're back with Andy Robinson, and the topic in this section, Andy, is the surrounding materials in a medical application and how it may affect a permanent magnet. So when designing a magnetic product, when you're working with these application engineers and these design engineers on a medical application, what considerations should you give and what should you talk with them about these surrounding materials in the application and why is it important?
I would definitely consider, what does the FDA approve if it's going inside the body?
Okay.
That's number one.
Mhm.
Number two is, when we're working with magnets, is we need to make sure what those materials are. What kind of steel is it, for example?
Okay.
Is it a ferrous material? What kind of effects can it have on the magnet? How
Mhm.
close is it to the magnet? So when we're designing these different applications, those are some considerations we really need to look at.
Okay. And so what happens to a field sometimes if there is a surrounding material that's, say, ferrous?
Well, that's a very good question. That ferrous material can actually pull the field towards it, which
Okay.
is not necessarily a good thing.
Okay. So for something like maybe a sensor,
Mhm.
is that could that be an issue because it pulls away from the sensor? Is that what you mean?
It can be an issue. It can either pull away from the sensor, or it can actually focus the field towards a sensor, which is also not a good thing, because in that case, we
Yeah.
would either trigger the sensor too early,
Okay.
or the field would shoot past the sensor and not trigger it at all.
Okay. So for these surrounding materials, what are some of the surrounding materials that you mostly see in a magnetic assembly?
Typically see some 300 series stainless steel.
Okay.
Definitely see different plastics. And
Okay.
those are really the two most common materials.
Okay. And Andy, there's this term out there that we throw around in the magnetics industry called shielding. And if you could you just explain what is shielding and maybe how does it help most in a medical application?
Sure. So shielding is taking ferrous steel, such as 1010 steel,
Hmm.
and we will put it, and I'll use this magnet as an example.
Okay.
You may actually put it on the backside here.
Okay.
And what that does is it blocks the magnetic field from going this direction.
Okay.
In turn, it will actually refocus the flux lines going this way.
Okay.
So it actually brings them in a little tighter.
Oh, so you can enhance or focus fields is what you're ending up doing.
Yes,
Okay. Do you actually purposely use shielding to pull away or push towards maybe a sensor or something else within a design?
absolutely.
Okay. Okay.
Absolutely.
And then when you're giving suggestions to designers about surrounding materials, what are some of the considerations that you would say, hey, Mr. Medical Designer, Mrs. Medical Designer, what should we do with this piece of surrounding material? What kind of those considerations do you give them?
Thickness.
Thickness, and why is that
Definitely want to
important?
consider thickness.
Okay,
Uh,
and
Go ahead.
I was going to say, why is thickness important in a surrounding material?
Because it creates air gap. And as long as it's a non-ferrous material, a magnet is going to see anything as air.
Okay,
So the thicker the material is, the greater the air gap we have between a magnet and whatever it's trying to attract to. And that is problematic for a magnet, especially a micromagnet that goes inside of a body.
okay, okay. So for air gap, can I just ask a quick question about air gap?
Yeah.
Is air gap a I guess a linear relationship? So if you're this far away, it's X amount of flux. If you're this far away two times, is it two times less, or does it drop off considerably? Why is air gap so important?
It does drop off considerably. Even by 1 millimeter, it can drop off. When we're looking at micromagnets, if you're increasing your air gap by 0.5 millimeter,
Mm-hmm.
it will significantly drop off. And it's because the flux lines are always going to travel the path of least resistance
Okay.
to find its mating pole. And in some cases, that could be the reverse side of itself.
Oh, okay, very good, very good. Oh, interesting, interesting. Okay, Andy, I'd like to move to the next section, which now is somewhat similar to this surrounding materials, but it's environmental influences on a magnet. And let's talk about how some of the other things within the area of the magnet can affect the magnet.
Okay.
We're back with Andy Robinson, and the next topic that we would like to talk about, Andy, are environmental influences on a permanent magnet or a permanent magnet assembly used in a medical application. So for first question out of the chute is, can you define what is meant by an environmental issue as it's related first to for a magnetic application?
Really, it's anything that takes place outside of the magnetics.
Okay. And like an example or two of that would be what?
In the medical world, we would definitely consider autoclaving.
Okay.
That is an environmental issue. And storage is also
Storage.
an environmental issue.
Okay. Okay. And storage that as we know in some of the world, storage is also in transportation, right? Where transportation considerations like heat or
Yes,
where it's going, those types of things.
definitely. Yes.
Okay. Andy, we work with customers in virtually every industry. And when we talk about environmental issues, we talk about different environmental issues, probably for different customers. But why is it so important for you to know about the environmental influences or the environmental issues as it relates specifically to a medical application?
It's a very good question. Really, the reason why we need to know is because these environmental issues can have a direct effect on the magnetics,
Okay.
causing failure.
Okay. So for an environmental issue, is something like heat a problem with a medical application?
Yes,
Okay.
it certainly is. The biggest factor would be autoclaving.
Okay. Autoclaving. Um,
Mhm.
okay. And then I also understand that there are situations where there could be a really huge magnetic field within close proximity of it.
Mhm.
Does that have an effect on the magnetics?
It certainly can.
Okay.
Uh, it- Two of the effects it can have is, well, one, that larger magnetic field could attract the device
Okay.
towards it, or if the device is secure, it
Mhm.
could actually demagnetize the magnet within the device.
Okay. Okay. So, Andy, what advice would you give to a medical customer that you're working with when it comes to environmental issues?
Would certainly, I would certainly ask questions about autoclaving temperatures
Okay.
and then storage conditions.
Okay.
How will these be stored in what kind of a room, in what kind of an environment? What are the surrounding materials, even the shelving?
Okay. Oh, okay. So the shelving, if it's magnetic versus non-magnetic, is that
Correct.
okay? So, Andy, what would best help you in order for you to best help your medical customers?
As much information as possible.
Okay, seems to be the theme, doesn't it?
It certainly is.
Okay. Okay, Andy, let's move on. Let's move on to our next section, which now we're going to start to get into simulations and optimizations of designs.
Okay.
I'm here again with Andy Robinson. This topic is simulation and optimization. For the people viewing this video, can you define the difference? What is simulation versus what is optimization?
All right. Well, simulation is taking a customer's parameters.
Okay.
Magnetic design really is what we're looking at.
Mhm.
And we're using software to simulate what they're trying to achieve magnetically.
Okay.
Optimization actually is a result of simulations.
Okay.
And it helps us, those simulations help us to optimize a customer's product. But that's not the only thing that helps us in optimization. It certainly is one of the key factors. The other key factors are working with the customer to understand every other aspect of the application so that we can incorporate that into the simulations and into their design
Mhm.
and optimize it.
So, Andy, when you simulate a design and you get results, and they may not be exactly what the customer wants, what are some of the suggestions that you have given customers in order for them to make that application more optimized?
We certainly look at the magnetic dimensions themselves. Can they be increased? Can they be decreased? What
Okay.
else is there? Can we add steel? We talked about that as shielding, but also using it to focus the field.
Okay.
Can we do that? Can we reduce housing thicknesses? Again, we talked about that earlier when it comes to air gap. So these are questions that we ask and recommend in order to make their product work.
Okay. So you've done. It sounds like you've done some good simulation optimization with your customers. In your opinion, how accurate is simulation?
I'd say it's fairly accurate. From what
Okay.
I've seen, I would give it a tolerance just in my experience of about plus or minus 5%.
Oh, okay. Okay. And then do simulations, do they direct you right into prototyping is what they do, or what do you usually do next?
That is usually the next step.
Hmm.
Or simulation and prototyping will go hand in hand. They may actually take place at the same time. A customer could be working on prototyping while we're working on simulations.
Okay, great. Andy, I'm going to ask you to think about two industries in this question, and I'll take them separately. And the first industry is a sensor application. And
Mhm.
when doing a simulation, what's most important for you to know in simulation when dealing with a sensor application?
Distance and location,
Okay.
and then, of course, surrounding materials,
Okay. Distance and location of what?
the magnet and the sensor.
Okay. Okay. And now I'm going to ask you to change over to a holding application.
Okay.
And in simulation, what would be most important for you to know in simulation for a holding application?
What are we trying to hold? How heavy is the object?
Okay.
And is there any air gap between the magnet and what it is attracting to?
Okay. Okay. So Andy, in the world of medical, it obviously takes some time to bring a product to market, just because of all the R&D that has to go with it and all the regulations that are involved. Um,
Yeah.
I guess in your experience, and this is just in your experience, approximately how many times do you think a medical customer simulates and then optimizes, and then maybe simulates and optimizes again? How many times does this process usually take place?
It's a very good question. It's not a fair question. It truly depends on the application. I have had some customers that we will simulate maybe 1 to 5 times.
Okay.
And I've had other customers where we will simulate 1 to 5 times per week. And we'll do this for a period of 6 months
Okay.
until we have optimized the design.
Okay. Last question under simulations, Andy, is that sometimes when a customer makes one tiny tweak to one part of the design, thinking that that solves the simulation or the optimization issue, they've optimized it by one little tweak. Does that have a domino effect, though?
It certainly can.
It certainly can. Okay. Is there an example of that you can give of maybe something that got fixed, but it had a domino effect someplace else?
Well, there is an example,
Okay.
actually currently working through that example.
Okay.
And we have run torque simulations
Okay.
and we optimized the design at the time. And the customer is actually looking to change the geometry of one of the magnets inside. So we've optimized. Now we have to look back and re optimize to make sure that everything still functions as it should.
Okay. Okay. Very interesting. So, Andy, would it be a fair statement to say in simulation, just like in the past topics we've had, the more information that you have about the application surrounding materials, environmental issues will help with the simulation?
Absolutely. Although it's not as important
Okay.
as some of the design considerations, environmental issues. Simulations only look at the magnetics, and we can incorporate steel. And of course, we can change the distance, the angle, and really we can look at what we're trying to achieve here. Some of the other materials are irrelevant because, again, a magnet sees non-ferrous materials as air.
Sure. Okay. Okay. Very good. Very good. Andy, I'm going to push us to the next topic if that's okay. And we're going to move into testing requirements and what is most important, I guess, in your experience and for customers in the medical world.
Okay.
I'm here again with Andy Robinson. We are now on the seventh section of this video for permanent magnets and medical applications, and we're going to look at testing requirements. So Andy, what kind of standard, if there is such a thing, what kind of standard test is done on a magnet for medical application?
The standard test we would start with is going to be a 24-hour salt spray test. And then, of course, dimensional testing. And then the third is going to be pole location to make sure that it's magnetized correctly.
Okay. And then what testing requirements do you suggest to customers for magnets that are going to be used in the body?
I would actually turn that question around to the customer.
Okay.
And ask them, how long is that magnet going to be inside the body?
Okay.
And that will help me to direct them on a salt spray test. That's going to be one of the best standards that we use is a salt spray test, the longevity of it. Again, the standard's 24 hours, but we may want to look at increasing that if the magnet is going to be in there for a period of time.
Okay. So Andy, what test would you recommend to a customer who maybe has a mini motor that's used in medical application, whether in the body or external of the body?
I would definitely look at torque simulations. And really, what is it? What is the output you're looking for?
Okay.
Really, we want to understand what the RPMs are so we can make sure we simulate this properly.
Okay. Okay. A final question here with testing requirements, Andy. I've actually heard you say, so I'm going to keep your words, keep you to your word here, is that the test should be appropriate for the application. Can you tell us what you mean by that?
Well, we definitely want to make sure we're simulating or testing the right things. So, for example, in a torque test, we don't necessarily need to be testing for pull force.
Oh, okay.
So that's not an appropriate test to run. For an application that may be outside of the body, we don't necessarily need to run a salt spray test.
Okay. Okay. Good.
So
as I see the theme here, more information that you have would allow you to recommend the appropriate test or testing for an application.
That's correct. And in the medical world specifically, customers typically have their own test requirements.
Okay.
So coming back to that same theme of the more I know, the better. So the more information I know about your testing requirements, the better off we will be.
Okay. Okay. Great. Great. Andy, we're gonna push to the next section, which we're gonna start to talk about intellectual property and NDAs.
All right.
I'm here again with Andy Robinson. Andy, in this section, we're going to talk about intellectual property and protection of that, and we're going to talk about NDAs or non-disclosure agreements that I'm sure you're very familiar with especially within the medical community. But when a medical customer contacts you, or you're continuing to work with your even existing customer base in the medical world, where do you start when it comes to IP and NDAs? Where do you start with a customer?
Well, it depends on the conversation.
Okay.
And what it is we're trying to understand. Eventually, at some point, an NDA is usually introduced into the conversation so that we can start understanding the details of the customer's application.
Okay. Have you ever rejected an NDA that has come from a customer?
One time.
One time. And do you remember the reason?
I do actually. And the reason is neither party could agree on terms that were mutually beneficial.
Okay. Okay. Yeah. I'm going to switch you over to IP. because especially in the medical world, there's a high level of responsibility on the supplier base to protect the intellectual property of the medical manufacturer. How do you do that? How do you ensure that that happens?
I work very closely with our staff, and we
Okay.
make sure that customers' information is not leaked anywhere.
Okay.
And we help to monitor that. I actually have a great example of that. One customer uh, had another supplier involved, and that other supplier leaked information
Oh.
on social media, as a matter of fact.
Oh.
And we caught it, and we alerted the customer immediately so that their legal team could take the necessary action.
And internally, so internally, do you have certain systems or processes or procedures that make sure that the IP is not going to find its way outside of the four walls?
Absolutely. And one of those, probably the most important one, is when we receive a customer's print,
Yes.
we clean it so
Okay.
that we make sure that nobody knows who the customer is, who the end user is, and really what the application is.
Okay. So Andy, um, I guess you may be different than other magnet companies in that not only do you have your own engineering group, but you also have your own manufacturing group. So they're all your factories, they're all your engineers, they're all your production staff. Is that is that more beneficial to a customer because everything is kept in-house, or do you see that as a benefit at all?
It's definitely a benefit, especially in the medical world, because the more controls are in place at one location, the
Mhm.
better.
Okay. And when it comes to IP, Andy, do you know the final design in most cases or not?
Not always.
Not always. And why is that?
Typically because it's not necessary information, really, that the customer sees necessary to share with us, as long as we understand what we're trying to work on within the application.
Okay. So a lot of the theme of this has been the more information you know, the better. But I guess the reality is that it's okay for you to know less at times.
Sometimes, yes.
Okay. As long as you know what the end goal is, it sounds like.
Yes.
Okay. Okay. Very good. All right, Andy, we're going to push to the final topic. And the final topic is record keeping, which I know is a big deal in the medical world.
Absolutely.
We're on the final topic. I appreciate the fact that you've answered all of our questions up to this point on the final topic of this series, permanent magnets and medical applications. The final topic is record keeping, because this is very critical in the medical world. Can you give an overview of some of the records that you work with in order to make sure that we as the supplier, or you as the supplier, are in compliance?
Certainly. Well, the first one is the NDA.
Okay.
That's going to be the first document that we maintain in-house. And
Okay.
then once we move on to production, we
Okay.
make sure we have the latest revisions of all drawings.
Uh-huh.
Any older revisions are marked as obsolete so that we know not to use them. So we
Mhm.
only use the latest revision. And then from there, when we're in actual production, it comes down to traceability. And that
Okay.
comes to a lot number. And that lot number follows the parts throughout all of production. And it stays with all the test reports, certificates of conformance, data sheets, those documents.
Okay. And approximately how long do you need to keep those documents for your customers?
Personally, I keep them forever.
Forever. Okay.
There's, I it, really, I mean, until the product itself changes,
Okay.
we want to make sure that we have the documentation in place at all times.
Okay. And as far as I mean, again, coming back to the fact that you own your own factories, uh, does your factory itself follow any kind of maybe like design processes to make, excuse me, manufacturing process to make sure manufacturing is done always the same way, or testing always done the same way? What do you kind of enforce onto your factory?
Absolutely. We put together DFMs, designed for manufacturing,
Okay.
really specifically for medical customers. And this is done at various stages. And it will even have different revisions
Okay.
based on, are there any geometry changes to the magnet,
Mhm.
or are there any actual production process changes to the magnet? And that can be anything from a grinding machine to a drilling machine, even all the way to tumbling. And
Okay.
so we maintain that. And we also have MTDs, which is really the test data. We have the SIPs
Okay.
and quality plans.
Okay. Okay. And when you put those together, do you actually share those with customers or do you just keep that close at hand? How does that work?
We absolutely share them with customers. We try to be as transparent as we can be so that they understand what's happening. And we want them to know that they have input.
Okay. Okay. So if I had to make a statement, whether right or wrong, you can correct me or not, it's that it sounds like all along the way, you need to say partner with the customer in order to make sure that you're in this together. Is that a fair statement?
Absolutely.
Okay. And for something like a process control or a test control procedure, who does have final say?
The customer.
The customer. Okay,
Yes.
that sounds great. Andy, I don't have any other questions. I want to say thank you. You've hung in there with me for these 9 topics. I appreciate it. Do you have any final comments that you would like to make before we end?
Well, just this has been fantastic. Thank you for having me. And really, within the medical world, it's an exciting world. We love to work there. And the theme of this whole conversation has definitely been the more we know, the better.
Very
So thank you.
You're welcome. For those of you that would like to reach out to Andy, we'll put his contact information on the screen as we fade away from this video. So again, thank you to Andy. Hopefully, those of you that have been watching have found this helpful. If you do need to reach out to Andy, please do so, and he certainly can assist you. So Andy, again, thank you.